Okay, an optimization problem involving designing a box-shaped aquarium. So, what do we know about this? Engineers are designing a box-shaped aquarium with a square bottom. The reason why that is important when you're drawing it, when you have a box, it means, and this is the base of the box, it means the length and the width are going to be the same size, so we could just call them length times length. And it has an open top, so that means when you're finding the surface area, because we're trying to decide how much glass we need to build this box, one of the dimensions, the top, we don't need. So that will come in handy. The aquarium must hold, so we know the volume, 500 cubic feet of water. What dimensions should they use to create an acceptable aquarium with the least? So you're minimizing. When you optimize, you can either find the maximum or minimum of something. So this is what we know. We know the volume is 500 cubic feet. We know that there's going to be no top, so that removes one of the measurements. It has a bottom length times length, but it has no top. That's another length times length that we can ignore. And the square base, that means the length equals the width. So the formula for this, remember it's volume. Well, normally, here, let's do the diagram first. So this is what it could look like, but remember, there's no top. The base is filled in. We can even put water. We can fill it all the way up with water, right? But this length and this width are the same. So we could say length times height, which is, I believe, what I did, height. There we go. Well, we also know the volume. The volume is 500 cubic feet. What I did here first, I wanted to know what H was in terms of L. So I got the H by itself, which is volume divided by L squared. And then I substituted in the 500 cubic feet. I did not. So we want to know what H is equal to because we only want to work with one variable when we're doing all of these. And we already have our L squareds. So my guess is that's what we're looking for. So the H is the volume divided by L squared. So that is 500 cubic feet divided by L squared. So that will be one that we need to remember. And this volume formula one we will need to remember. All right. So let's see. And then we've got surface area. So normally if you have a completely closed box, so it has, you get a package from Amazon, it has all sides, the surface area for a rectangular prism is twice the length times the width, the bottom and the top, twice the length times the height, so that's the front and the back, and then twice the width times the height. That's the left and right side. But in this case, we don't have the top that we have to worry about, so that cancels. And we know that W and L equal each other, so instead of W, I can put an L. Now look at, we have two L times H's and two L times H's. So surface area is L squared plus 4 LH, and this is why we needed to know the H. It's because we've got L's we're dealing with. We don't want to deal with an H. So I'm going to pause this and then put in the formula. Okay, so it's the surface area because we need to find the dimensions of the glass. So it's that outside area that we need to optimize, and we need the least amount of glass to produce the box or the aquarium that has 500 cubic feet. So this is our formula, but instead of H, remember what H was. So L squared plus 4LH, and H is 500. I'll leave the cubic feet off right now, over L squared. Well, look at what happens now. That L and one of those cancel. So now we have surface area is equal to L squared plus 4 times 5 is 2,000 over L. Well, now we are ready to take the derivative and to start the optimization process. So the derivative of the surface area, and sometimes people leave off the S, but usually when we have area, it's for inside things. So I like for people to know that we're talking about surface area, so I leave the S. So the derivative of L squared is 2L. And then remember, anytime you have the product rule where there's a constant over a variable to the first degree, that derivative ends up being subtract that constant over L squared. Okay, so now I'm going to set this equal to 0, and while I'm doing that, I want these two to have the same denominator as this, so I'm going to multiply the numerator and the denominator by L squared. So now I have 2L cubed minus 2,000, all of that over L squared. Well, I don't like this denominator, so I'm going to multiply both sides by L squared. Well, L squared times 0 is still 0. And now look at 2L cubed and 2,000 have a 2 in common, so I'm going to factor out a 2, and that will leave L cubed subtract 1,000. Here is a big hint. If you've got something cubed, subtract a number, check to see if this has a perfect cube, and it does. So when you take the cube root of 1,000, you get 10, and we are talking about feet. So 10 feet, we know that the width and the length equal each other. We just have to find the height. Well, we know the height is this. So now we can substitute 10 squared. Well, 10 squared is 1, and squared means feet squared. Well, feet cubed, so let me write this bigger so H is equal to 500 feet cubed over L, which is 10 feet, squared. Well, that's 500 feet cubed. 10 squared is 100. Feet squared is feet squared. Remember the laws of exponents. 3 subtract 2 is 1. 500 divide 100 is 5. So our height is 5 feet. So now the dimensions that we were talking about for the glass, to minimize how much glass we use for that aquarium, is the length is 10 feet by the width, which is 10 feet, by the height, which is 5 feet. All right, that's it for this one.